Hello students, welcome to Sri Jayendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 18 of a unit motion in a straight line. So let's begin with today's class. In today's class we are going to discuss about the previous year asked questions. This is part 1 as I have divided this segment, previous year asked questions, into two segments. One of the in first part we are going to cover the questions that has been asked and that can be asked or most probable into the medical examinations, and in the next session, in the next part, we are just going to discuss that all those questions that have been asked previously in the JEE examinations and they are having a higher probability to be asked in JEE examinations. But I request that whether you are a medical aspirant or you are a JEE aspirant, please go through both the parts, because there we cannot segregate exactly that this is the questions that can be asked in JEE only or this is the question that can be asked in medical only. So please, these are very small videos, these are very small lectures, please go through it. And one more request from my side is that before you start this and before you go through this video, please have your pen and paper, because we have already covered the complete unit motion in a straight line. So you must know each and every topic, you must know each and everything, you must be aware with the each and every concept, and this is just like an examination. So please be ready and let's do it with me. So let's begin with today's class. All the best guys. Let's move on. Yes, what the data is saying. What they are saying is a goods train accelerating uniformly on a straight railway track approaches an electric pole which is standing on the side of a track. Its engine passes the pole. It's an engine, so it is a beginning point with the velocity u, and the guard room passes the pole with velocity v, so it's an ending of the train. The middle wagon of the train passes the pole with a velocity of, yes, so they have just said that it is an initial velocity, that is u, it's an final velocity, that is v, and you need to find out the velocity of a middle wagon of the train passes the pole with a velocity of. So how can you do this? How can you do it? Let's look at this. Let's say this is the pole P, and here the train would be there. When this train reaches here, that means just engine is passing this, that velocity u. When the situation seems like it is just an ending part, I hope you understand this. This is v, and when the midpoint is there, let's say this as a vx, when passes this pole, I need to find out the velocity of this. I am interested in vx. So what can I do? So what basically I assume it that let's divide this length into two segments. It's an x and x because it is a midpoint, so I can assume this, that this total length would be a 2x. The velocity of this segment, it is u, the velocity of this segment, it is v, and the velocity of this segment which is at the midpoint, it is a vx. So I have a relation that v square minus of u square should be is equals to 2ax. This is my master relation. Now my distance from this train, it's x plus x, it is a 2x. So what I can have is, it's an v square minus of u square should be is equals to 2 into a into 2x. So this should be 4 into ax. This is equals to v square minus of u square, and I can write like v square minus of u square divided by 4 should be is equals to ax. This is the value of an ax, and keep it aside, maybe it can help us. Now I am interested in this, so let's consider only this much amount of journey, It's a journey while train is traveling a distance x only. While train is traveling a distance x only. So my final velocity would be a Vx. So this is Vx square. My initial velocity, it's an velocity u. It's a u square. Should be is equals to 2ax. So this look alike Vx square minus of u square divided by 2. And that should be is equals to ax. I can write this relation as a 1. I can write this relation as a 2. If you look at this carefully, if you look at this very very carefully, it's in both the sides I am having an a into x. So I can relate this two relations. And if I relate this two relations, what I can have is it's in v square minus of u square divided by 4. It was the first relation. Should be is equals to Vx square minus of u square divided by 2. So this is 2 2s are 4, and let's solve it. So this could be v square minus of u square should be is equals to 2 into Vx square minus of 2 into u square. I am requiring this. It's a 2 into Vx square should be is equals to v square minus of u square. This is plus 2u square. This is plus 2u square. This is minus of u square. So I can write this as a v square plus u square. And this is, if it is a Vx square, then this should be divided by 2. So what I can have relation is Vx should be is equals to root of v square plus u square divided by 2. This is the relation that I can remember for this kind of questions. I can remember this. This will help me. Yes. So this is the final answer. I hope you understand this. Yes. Before you move to the next, let's just quickly revise this. What I did is that my segment in my question, they have asked about the middle point. When they ask about the middle point, I have divided my complete length into two segments, distance of x and x. So that will help me to calculate very easily. So I have considered the distance of 2x. Yes, so because I can divide it into two segments, and all the segments will be having a length of x only. I have applied the relation v square minus u square equals to 2ax, and then I compare just two values of ax, and the things will be done. Please remember this, because whatever the numericals we are going to perform in the next slides, this will be based on this only. Let's look what they have given. A car is moving along a straight road with a uniform acceleration. It passes through points P and Q separated by a certain distance with velocity of 30 km per hour and 40 km per hour respectively. Velocity of the car exactly midway between P and Q. Yes, this is the question they are asking. How can I do this? First, let's have a rough sketch of this. It passes through points P and Q separated by a certain distance with a velocity of 30 and 40. That means maybe it is moving in this direction. This was the P, this was the Q. This would be a 30 km per hour. This would be a 40 km per hour, and car is moving in this direction. Here somewhere midpoint is there where you require to find out the velocity. Now two approaches could be there. First, you again derive this, or second, if you remember this, if you remember the formula, you can directly go for it. Yes, so we must learn this formula. It's a Vx should be is equals to root of v1 square plus v2 square divided by 2. So according to the data, it's a 30 square plus 40 square divided by 2. So this is 30, that means 900, 40, that is 1600. 900 plus 1600, it's a 2500. Yes, and if it is 2500 divided by 2, it's a root of 1250 kilometer per hour. I hope these things are clear to you. Is it? So can it be done? Can it be done? This kind of questions. Can you do this? Are you sure? Can I have one more question like this? May I? Let's begin. In the previous question, find velocity of car when it has traveled one third distance from point P, and this was the situation. This is the VP, this is the VQ, and they have given in the previous question that this would be a 30 kilometer per hour and this is 40 kilometer per hour. Now you require to find out the distance, find out the velocity when it has traveled one third of the distance, one third of the total distance from the point P. So maybe it would be here. I can divide this into 3 segments and I require my velocity at this point. Do it by yourself. Do it. I hope you can do it. Take your time of 10 seconds and yes, can you do it? Is it? Can it be done by you guys? Is it? Okay, let me help you. What we can do is that this is one third of the distance. So if I wish, I can divide this into 3 segments of same distance. It's in, let's say this is X. This is X. And this distance is X. Yes. And let's begin with that first complete journey. That means it's in VQ and VP. VP is the initial speed, VQ is the final speed. Let's say this as a V1 and this as a V2. So what I can have is it's in V square minus of U square. This is equals to 2AX. This should be my master formula. So this is V2 square minus of V1 square should be is equals to 2 into A into total distance. It's a 3x. So this is 6AX. That is equals to V2 square minus of V1 square. So if I want AX, it's in V2 square minus of V1 square divide by 6, and that should be is equals to AX. This is my first relation. Now I can consider only this journey starting from VP and ending from VX. So in my case it's starting from V1 and ending on the VX. So Vx is the final speed and Vp is the initial speed. So what I can have is it's a Vx square minus of V1 square. That should be is equals to 2AX. So I can write like this. It's a Vx square minus of V1 square divided by 2. That should be is equals to AX. Now as we did this in previously, I can compare this to AX. So if I compare this, it's a V2 square minus of V1 square divided by 6. That should be is equals to Vx square minus of V1 square divided by 2. This is 2 3s are 6. So I can write like it's a V2 square minus of V1 square should be is equals to 3 times of Vx square minus of 3 times of V1 square. So this is V2 square minus of V1 square plus 3 times of v1 square should be is equals to 3 times of vx square. So this is minus of v1 square plus 3 1 square. It's a v2 square plus 3 minus 1. It's a 2. v1 square divided by 3. This is equals to vx square. So what I can have is, it's a vx that would be equals to root of 2v1 square plus v2 square divided by 3. Yes. Now my v1 was 2 multiplied by 30 square plus 40 square divided by 3, and I hope you can solve this in kilometer per hour. Yes, can you do this? Can it be? Is it possible by you guys that this can be done? Is it? Are you sure? Yes. So please look at this relations very carefully, because this question has not been asked from last 3 years, last 3 to 4 years. Yes, so they are having a higher chances to be asked. Okay, let's move on to the next question. Let's look at it very carefully. Yes, what the question says, it says a person climbs up a stalled escalator in 60 seconds. Okay, if standing on the same but escalator is running, that means a person is standing, he is not moving. With constant velocity he takes 40 seconds. Okay, how much time is taken by the person to walk up the moving escalator? Yes, so here he has given a situation that if a person climbs up a stalled escalator, that means escalator is at rest and person himself is moving, then he can reach to a certain point in 60 seconds. Now if the situation reverse, that if person is standing on the same but escalator is running with constant velocity, then he will take a 40 seconds to do the same task. Now what would be the time taken by the person to walk up the moving escalator? That is what they require. I hope those things are clear to you. Is it? Yes. So what can I do is that I can write like this. It's an velocity of person plus velocity of an escalator. That should be is equals to Vp plus Ve. Yes. Now velocity of a person, that would be equals to, let's say, L divided by T1. Velocity of an escalator, it is an L divided by T2. That would be is equals to, this would be equals to L by time taken T. Yes. So this L could be a gone, and what my time is 1 by T is equals to 1 by T1 plus 1 by T2. Yes. So I do the same thing. It's a T is equals to T1 into T2 upon T1 plus T2. Yes. So this would be a 60 is given, a 40 is given, and divide by 100, it would be a 24 seconds. Very easy question. A same question has been asked in before 2 years, that Preeti wants to reach from this point to this point and on escalator, and same kind of questions has been asked. Yes. So can you do this? Can it be? Are you sure, guys? Will you be? Great. Let's move on to the next question very quickly and do it fast. What the data is telling, what the data is asking, they says that a car moving with a speed of 50 km per hour can be stopped by brake at least 6 meter. If the same car is moving at a speed of 100 km per hour, that means double of this, the minimum stopping distance is, yes, when we have attempted this kind of questions, we have already discussed that this is the one of the approach. But what we are going to do is, we just going to take a ratio of this, and when I take a ratio of this, I know that my stopping distance is directly proportional to the square of the velocity. So let's put up the value. It's a stopping distance of 1 is to stopping distance of 2. That should be is equals to u1 by u2 whole square. A first stopping distance would be equals to a 6 meter. A second stopping distance would be equals to a s2. First velocity, it's in 50 kilometer per hour. No need to change because it is a ratio, and at the end of the day it is going to cancel up. So it's in 50 divided by 100 whole square. When it is 50 divided by 100 whole square, this is 1:4. And if I write this S2 is equals to 24 meter. This would be the answer. Yes, I hope these things are clear to you. Is it ready to move the next question? Yes, let's move on then. What the question says. What this says is, a car starting from race accelerates with 5 meter per second square and reaches a maximum velocity, that means even Vmax is given. Then by applying brakes, it comes to rest with a deceleration of 8 meter per second square. The total time of the journey is required. How will you do it? How can you do it? Do you remember a same pattern of questions that we have done already in the class? Do you? Do you remember this? How did we did it? Yes, you might assume it correctly that we have plotted one graph in which it's a graph of V versus T, and it has started from rest and achieves a maximum velocity. This is Vmax with certain acceleration A1, and then ended up here with certain retardation A2, and the total time of this journey was the A. When we find it out the Vmax, we just write that it is an U plus A into T, but this U equals to 0, so it is having only AT, and we write A as an differently. It is an A1 into A2 divided by A1 plus A2 multiplied by total time 10. This is Vmax. This we have already derived this. If you don't know this, please go through that class and just see it, but this must be remembered. So this is Vmax is equals to A1 A2 upon A1 plus A2 into T. Now let's look at the data. What I am given is that my Vmax is 20. Vmax, it is a 20. My A1 is 5 and A2 is 8. A1 is 5 meter per second square, and A2, it is an 8 meter per second square. So this 20 is equals to A1 A2, it's a 5 into 8 divided by 5 plus 8 multiplied by T. So if I solve this, it's a 20 is equals to 40 by 13 into T. So this is T is equals to 13 by 2, or it would be an 6.5 seconds. This would be the answer. Yes, I hope these things are clear to you. Is it? Okay. So shall I ask and shall I add something new to this? That in the previous question, find first total distance traveled and next average speed of the journey. So how can you do it? Let's begin with the first question. It's a total distance. So total distance x can be calculated as an half into a into t square, but you are going to write a as an differently. It's an half multiplied by a1 into a2 divided by a1 plus a2 multiplied by t square. Now this is 1 by 2 multiplied by a1, it's an 5, multiplied by a2, it's an 8, divided by 5 plus 8, it's a 13, multiplied by, this is 6.5 into 6.5. So this is 6.5 2s are 13. Yes, 6 2s are 12 and 0.5 2s are 1. It's a 6.5 2s are, it's a 13. So this is 5 8s are 40. 40 by 4, it's a 10 into 6.5. So this would be a 65 meter. I hope even you are having a same answer. Is it? Great. Now let's work for the average speed of the journey. How can you do it? What is the formula of average speed? What is it? Yes. Yes, average speed second. It's a total distance divided by total time. Now total distance is half into a1 a2 divided by a1 plus a2 into t square divided by total time t. So this t would be a gone, and what I can have is it's an half multiplied by, it's a 5 into 8 divided by 5 plus 8 multiplied by time, and this time was the 6.5 seconds. So this is equals to 1 by 2 into 5 8s are 40 divided by 5 plus 8 13 multiplied by 6.5. This 6.5 2s are 13 and this is 40 by 4. It's a 10 meter per second. This is the average speed of the journey. I hope these things are clear to you. Is it? So can it be done? Can it be done by you guys? Are you sure? Can it be? Okay, let's move to the next question very quickly. A very important question. What they have given is a particle simultaneously participates in two mutually perpendicular oscillations which are given as x is equals to 2 sin omega t and y is equals to 2 cos omega t. The trajectory of this motion will be, okay, how can I do it? What I have been given is x is equals to 2 sin omega t and y is equals to 2 cos omega t. So let's square this, which will give me an x square is equals to 4 sin square omega t and y square is equals to 4 cos square omega t. Let's say this is relation number 1, this is relation number 2. If I add this, then what I can have is it's an x square plus y square is equals to 4 because sin square omega t plus cos square omega t is 1. So if I can relate this with a standard relation of circle, it's an x square plus y square is equals to r square, where r would be the radius of the circle. Then this trajectory represents the circle having a radius of 2 meter. So this is the equation of a circle, and this represents a circular trajectory. I hope these things are clear. Yes, is it? So if a same kind of question has been asked, that if x is equals to a sin omega t and y is equals to b cos omega t, then the trajectory of motion will be, all other datas are same, with respect to previous question. So what can you do? What I can have is, can I write like this? It's an x by a is equals to sine omega t, as well as y by b is equals to cos omega t. So it's an x square by a square should be is equals to sine square omega t, and y square by b square is equals to cos square omega t. So this is relation number 1. This is relation number 2. So if I can add this, it's an x square by a square plus y square by b square, that would be equals to 1. And this is an equation of ellipse. This is equation of ellipse. So if these two terms are equal, it would be in circle. And if these two terms are different, this is the equation of ellipse. You are going to learn about the circle and ellipse in more detail in the unit gravitation. But here you must remember that x square plus a square, x square by a square plus y square by b square, that should be is equals to 1. I hope these things are clear to you. Is it? Yes, I hope these things are clear to you. So can you do this kind of questions? Are you sure? Let's move to the next question. Go with this. What they have given. What they have given. What they have given is, it's a displacement of a particle that has been provided, and you need to find out the ratio of its initial acceleration. That means acceleration at time t equals to 0 and initial velocity. Okay, so before we go through this, first I need to find out the velocity and acceleration. So displacement is given, velocity is to be find it out. How can I do it? Yes, with the help of differentiation, v should be is equals to dx by dt. So this is d by dt of alpha t cube plus bt square plus gamma t plus delta. Now alpha t cube, it's a 3 alpha t square plus beta t square, it's a 2 beta t plus gamma t, it's in gamma. And velocity, if I find it out, yes, delta would be a 0, that you know. If I find it out that velocity at t is equals to 0 seconds, velocity at t equals to 0 seconds, this would be a 0, this would be a 0, only the gamma remains. It's a gamma. This is the v. Now what you need to find it out, you need acceleration as well. Then that a is equals to dv by dt. This is equals to d by dt of 3 alpha t square plus 2 beta t plus gamma, that should be is equals to 6 alpha t plus twice of beta, and gamma would be a 0. So if I put acceleration at t equals to 0, this would be a 0, and only the term remains, that's a 2 beta. Now I need to take a ratio of this. I need to take a ratio of the initial acceleration to initial velocity. So a initial to the velocity initial should look alike. A initial, it's a twice of beta, and velocity initial, it was the gamma. So this depends only on beta and gamma. Here 2 is a constant. I hope those things are clear to you. Is it? So let's wind it up here. This was the part 1 of previous year asked questions. In the next session, we are going to meet with some more questions, some more difficult questions, because it could be asked and it have been asked in the JEE examinations. So bye bye, take you, bye bye, take care, thank you, and have a good day. And be ready for the next session. Revise it thoroughly. Thank you.